All right, welcome everybody. My name is Bill Degnan, and it says William, but my name's Bill. I am the curator of the Kennett Classic Computer Museum, which you may have any of you ever heard of that? It's in Kennett Square, Pennsylvania. It is currently not open because our lease ran out after 5 years. But we did a lot of tours, and we had hundreds of computers. And 5 rooms full of computers. It was a lot of fun. So hopefully opening up again soon. I'm doing a talk about the history of AI, which is completely wide open, kind of a topic. I bet you if I asked each and every one of you what you think the history of AI was, you would probably have a different interpretation of it. This is simply my interpretation of it. And what I'm going to focus on a little bit more is on the cultural end of it, and a little bit less on the technical end of it. We only have an hour, or so we're going to have to move quickly. Okay? Let's see if this works. Awesome.
It's fine now.
All right. We'll see if this works. Okay.
Is it blocking your view?
I'm going to break the history of AI into sections, and we're going to start with automatic machine tools. What I'm really talking about here is we're going to start in the 19th century, because we're ultimately going towards artificial intelligence as it's used by a computer-enhanced artificial intelligence. But before there were computers, there were computing devices. And so I'm going to talk a little bit about that first, because that helps put things into context. You can see thermostats, centers, counters, and so on. Okay. One of the first examples of machine-aided intelligence was the Jacquard loom, which was essentially the same thing you would have a player piano with punch cards, but it was a long strip of cards that were connected together, and they would create the patterns for a loom that would automate the process of making fancy or custom designs in printing. This was invented, weaving, 1804. And that's a cigarette card from 1916. I should back up and say one more thing before we continue. The contents of this lecture are 100%, or I'd say 99% is one slide, but 90-something% is all from the Kennett Classic Library. So everything you see here is from the actual library itself, all the research and all the materials. So ChatGPT was not used at all. I didn't just ask ChatGPT to spit this out and then print it out and do a talk. I'm also going off of my memory, and I'm also happy to answer questions. But I want to make sure I'm making that clear, including this card is in the actual library itself. And hopefully will be open again for people to use it. Okay. 1833, Charles Babbage, I'm sure you've heard of him. He created the difference engine, and he also continued on an analytical engine. In his mind, he was making what effectively is a mechanical calculator. But in his head, he was working towards making an analytical engine that would give him the ability to actually program it. A lot of people say, well, there's no way to really prove that, but the documents that I have, including the one right here, talks about him talking about actually creating a tic-tac-toe computer. This is his interview in 1863, and he says no reason existed within the machine to direct its choice. Some provision were made the machine to attempt 2 contradictory motions. The remedy was to keep record of the number of games that won from the commencement of existence. So he's talking about memory. So in 1863, he's already talking about computer-aided intelligence. He's such a brilliant person, really, on his own. He realized the significance of what actually didn't become his analytical engine, but he saw where he could go with this. And I think it's interesting that tic-tac-toe in the 19th century was called tic-tac-toe, but that's a whole other thing. Okay. And it's going to be a little slow because I'm going to have to. Is there a way that I can?
If you just click on here.
Well, I understand that, but I mean, Okay. But what we're doing right now is we're building the things you needed in order to have computer-aided intelligence. In addition to having a machine that could perform calculations, you also needed a machine that could tabulate and store data. The key to today's artificial intelligence is the combination of the storage and retrieval of data and the computer power and the programming associated with it. There's hardware, there's software, there's data. That is where we're going with computer intelligence, computer-aided intelligence. That is where we are today. And so this is a very important machine. Herman Hollerith in the late 1880s invented the card sorting machine, which eventually became IBM's company. This was used, I believe the story is the 1890 census was the first time that there were too many people, and it took almost 10 years for them to tabulate the 1880 census. The 1890 census was coming up. They needed to do something. So Herman Hollerith got the job to do the tabulation by use of punch cards. And so it was the United States government that was the first big user of big data by doing a census with aided intelligence. It was the ability to do massive quantities of data in a standardized fashion. Okay. Okay. So we're going to now jump from the 19th century to the mid 20th century. So I wanted to you know, I could bring a lot more devices. How many people here are not familiar with a mechanical calculator? You pull the arm and it basically does the math like a handheld calculator. Okay, we're all on board with that. Okay, so I just wanted to make sure that I painted that picture that these things existed, that calculating and human aided intelligence devices existed before computers. Okay, but now we're going to go into the next important part of what became computer aided intelligence, which is symbolic reasoning. This is being able to have a machine say yes or no, digital, or have reading of voltages in an analog computer in order to determine a result. And that's what symbolic reasoning is. It's the representation of a response. Whereas a mechanical calculator, when you pull the lever, it pulls a bunch of switches and gives you the numbers. Symbolic reasoning doesn't use that principle because the machines had to get bigger and bigger and bigger to the point that it became impractical. So something needed to be done beyond what was just simply the use of a mechanical device to tabulate a whole bunch of relays and arms in order to come up with a number. Okay. Alan Turing, I'm sure you've heard of him. His paper, Computing Machines and Intelligence. In a lot of ways, you can consider this to be part of the early modern era of computer artificial intelligence. He had two major things in his paper in 1950. Was the Turing test, and the other was the halting problem, or addressing the halting problem. The halting problem is simply a machine knowing when it's time to finish. Did I get the answer? Am I done? Have I correctly responded and presented a response in such a way that's relevant to the question of, you know, a human being asking a machine a question? Did I give what's the appropriate answer? And of course, the Turing test is to actually mimic human intelligence to the point that a human being wouldn't be able to differentiate between a computer's response and a human being's response. Give you a simple example. What he was talking about at the time, having a teletype in a room, a person sitting in front of a room asks a question, waits a while, the response comes in, and the human being looks at the response, and through a series of questions and answers, not being able to differentiate between the human being and the computer's intelligence. Okay, so when people talk about the Turing test, it evolved over time, but that's what he was talking about at the time, and that was his benchmark for determining a computer-aided intelligence's success. So that was his test for true artificial intelligence. And you can argue whether that's we've reached it or not, but I'm going to talk about how we've evolved culturally to be more skeptical of answers that we get from computers as well. And so we've never quite made it. And it's in a way, it's kind of like like a tangent onto it. We're never going to quite get there. Okay. Another important component of artificial intelligence was the concept of a neural network. This is in a lot of ways an algorithm or an object in the simplest terms. You can have this be mechanical, you can have this be computer oriented, but what a neural network is a series of more and more and more. It could be one, it could be 10, it could be thousands, it could be millions of objects working together in order to massage and determine whether or not an answer is appropriate based on the feedback mechanism of some sort set up by a program. So I was surprised in my research to find that this was talked about theoretically so early during World War II like that. I didn't even know that. I thought it would have been a little bit later, but just so you know, these ideas were around right off, and that they weren't just invented in the past 10 years. Okay, heuristics. This is another term. This is another component that was very important for the development of artificial intelligence, because if you can't ask questions like or, and, nor, and exclusive or in your programming code, if you can't do that, then you can't branch your decisions. If it's raining outside, then my artificial intelligence knows to roll the window up in my car and not just open it and close it randomly, you know. So there's a sensor, there's a thermostat, there's a water gauge. It determines whether there's enough moisture on the window when it's time to roll up the window. That's not necessarily a artificial intelligence as like a human being talking to another human being. But artificial intelligence is more than just that. It's also just anything that works on its own autonomously and correctly. And then randomness, this wasn't really specifically touched upon in a lot of the documentation that I read from the 50s, but I think this is also very important because humanity has a random component built into it. You may decide that you want a piece of cake on Monday and Tuesday and Wednesday, but for whatever reason on Thursday you decide you don't want a piece of cake anymore. And it might just be randomness. Sometimes human beings actually prefer the novelty of it not being the same over and over and over again. So part of artificial intelligence is how to program a degree of randomness so that you mimic that taste change and that novelty that humans tend to prefer in their everyday life. Okay. This is one of the earliest devices that I could find that performed binary logic. It's called a homeostat, and it's a series of compasses suspended floating on water. And so when the current would change on the poles, the compass would automatically move to the pole and complete the circuit, because of the fact that it was floating on top of water like a little boat. And so these devices, this was described in radio electronics in 1949. And so I just made a scan of it. It's not the first, but it's a good example of the kind of experimentation that people were doing before and during that initial phase of computers being developed. It's that binary concept. And this is very important for digital computers. Okay, I probably touched on a lot of the other things here, but the idea of symbols used for problem solving, and I guess the only other point that I haven't made already is that analog computers have one complex program at a time. Electronic computer design accepts instructions with a set of rules. At the time in the 50s, analog computers were more precise. Electronic computers were more flexible, but they weren't as fast and they were expensive. So there was we'll come back to that, but okay. But this is a great example of an early analog computer. They handle information as a measure of physical quantities like voltages, and you can see here Simon, which I think is considered to be the first personal computer. And this is a portable computer. You can see it there. The woman is looking at the guy instead of looking at the computer, but Edmund Berkeley and I think he and Robert Jensen together designed this thing as a prototype. And what it would do is you would feed equations into it by putting amplifiers in a row, and you would send a pulse of amplification into a circuit, which would then work through the capacitors or the diodes or the crystal or whatever was in that circuit, and it would give a result in voltage. For example, if you wanted to determine the slope of a decline in particles per million, and you wanted to count those, you would be able to use an analog computer to measure them, and then it would plot it onto a plotting paper. I thought this was interesting. This is the manifestation in 1956 of almost 100 years later from what Babbage had mentioned as a computer being able to do, which is play tic-tac-toe. You can see the electronics behind it are much easier to work with than what he would have been trying to do without electronics in the Civil War era. Okay, and then here's a great example of the Electrodata 101. Can anyone tell me the company that bought Electrodata? Burroughs. And they renamed it the Burroughs B101. But this is one of the very first electronic computers. And it actually worked with decimal. So it was an electronic computer that didn't use binary, it used decimal logic. And so the instruction set for this computer was in decimal. This is a little card that comes with the computer, and you know, you can carry it with you. This tells you how it works. So digital means handling information characters digits in the way the fingers can express it in their hand, versus voltages or measurements. Okay, so what I'm doing right now is I'm walking through the things that were happening in the 50s that were relevant to the development of artificial intelligence. So at this point, and you can also see, okay, we'll go to the next one here. Here's a UNIVAC computer. This is actually from the museum in Munich. I actually took this picture myself. This is Remington Rand's UNIVAC division of Remington Rand until it became UNIVAC itself. But this is I guess you call this the CPU of the computer. They were huge back then. And I think that that's an important thing to state, that analog computers were much smaller. They were portable. You could take them to a job site and you would program them to solve one specific problem, but it would do it very well, very smooth lines. In order to replicate that with an electronic computer, you couldn't take this into the field, and you had to spend an awful lot of money to get the same result. But in the end, electronic computers were more powerful because of the fact that it didn't need to reset the program every time you ran it. This was a flexible computer. The UNIVAC 1 is one of the very first computers where you actually just program it. And this next slide just talks about, this is from the manual. So this is 1954. This is just talking about if you wanted to buy a UNIVAC, this in the manual they're talking about that it sorts, and it talks to you about how it sorts. So sorting is very important as well. If you're going to be doing artificial intelligence, you need to be able to sort information. There's a little bit of a smaller computer, the IBM 650. This is important because this was the computer that a lot of the institutions and universities kind of gathered around as a practical machine to have in a university to start the science of, or the computer engineering departments. So a lot of the very first computer engineering departments would have an IBM 650 in their computer labs. It wouldn't be called even necessarily a computer lab. These were so famous at the time that when the University of Iowa got one of these, it was actually in the newspaper, and they named it the Cyclone, and they were very proud of it because it was the only computer in Iowa. So at the time, to have something like this was very novel and extremely expensive, and it was really something that said that we're serious about engineering at the University of Iowa, and we're going to have the vision to move into computing. At the time, computing was automation of the punch cards, counting lots of numbers, sorting people, the military uses of computers, targeting and so on. It wasn't like people were walking around going, boy, I want to connect to this thing and I want to do my home accounting with it. That wasn't in the minds of people. It's important to understand from an artificial intelligence standpoint that the computers of that time are a reflection of the people who are operating them. So the intelligence in a lot of ways is only as good as the people who have the ideas and how to program them and the languages and the machinery that's behind them. This is a very basic computer in today's uses, but it's an important stepping stone because before this, there was no such thing as computer science. 1956 in Dartmouth. Dartmouth is another college that was very important to the beginning of artificial intelligence. This is like the pantheon of the artificial intelligence, birth of artificial intelligence. John McCarthy had a 2-month, I suppose it was a series of lectures, and these gentlemen were members of this team of people who got together. They coined the term artificial intelligence, and they began coming up with ways to use these new computers in ways beyond just insurance companies and counting people and how many of them are living in one state versus another state, what populations of farmers are, and so on. What they were thinking is, wow, we could take this data and maybe do things with it in ways that we have never even considered before. We're enhancing artificial intelligence beyond what can be just done with a mechanical calculator. So this is a very important team of people for coining this phrase artificial intelligence in 1956. And here's some examples of artificial intelligence, including the program for musical composition, the logic theorist, game playing program, and the general problem solver. My gigantic mainframe computers are all at home right now. It's hard for me to bring them in. But I do have this one, the program for musical composition. So I thought that I'd play this for you. This is an example of artificial intelligence generating music. And this is the first record that was published of artificial intelligence generated music. So I'm going to play for you the last song on this recording. This is the closest thing to computer generated music, whereas the other ones are. One second. Let's give you a little background here. So the first 3 songs are music that musicians wrote guidelines that were programmed into the composition that then the computer would randomly generate intervals and so on. This last one is let's let the computer do whatever it wants. Okay, so what you're hearing for the first time, or what was recorded for the first time onto an album, is what a computer just came up with on its own. Hopefully this will sound good. All right, so this is the end of the other one. Makes you want to dance, doesn't it? There it is. So you can hear there's not a lot of soul in there. It's not a composition to dance to or to. This is more of like some sort of mutant birds are running after you, and it's dark, and you're in a cemetery, and they're trying to get you, and you just barely made it into the house, and it's that kind of stuff. So that was interesting. So it's because it's got that eerie oddness to it. Yeah,
It's got tension.
it creates which is weird. So the computer naturally generated this, what humans would consider to be tense music. All right. So only a history person would care about that. Yeah.
What's the style of the previous set of music? It sounds very much something like this.
I would say if you'd like, you could read. They explain it on the album. I don't have committed to memory exactly what it is, but they're basically more talking about the process and the idea behind getting it successively more computer oriented and less composed and kind of like how today in ChatGPT or not that, but you can ask artificial intelligence to make a song that sounds like it's the Beatles, and you listen to it, and you're like, oh, that sounds like the Beatles. It's not the Beatles. Well, that's what the earlier music was the equivalent of that, but it's being played by it's actually spitting out music score, and then musicians actually have to sit down and actually perform it. This music that we're just playing is probably at the edge of what human beings would be able to read and perform as a musician. You know, going, I mean, that would not be something easy for somebody to do because there's no tune behind it. You're just, you know, you're becoming a machine. You're literally. It's not the artificial intelligence in a lot of ways is so pure that the human isn't there. So it kind of fails the Turing test if you want to think of it like that. Any other questions? I just think it's great that I hadn't have this record that I could demonstrate this. But if you wanted to ask yourself about a game playing program or general problem solver, you're going to get that same level of quality, which is not very high. But they were trying to make it work, and they were writing programs with an effort to try to generate artificial intelligence. You have to start from somewhere, and that's what they were doing. Okay, this is the computer that I believe that they used to. This is the most sophisticated computer of 1959. The Stretch IBM 7090. There might have been more advanced computers than this, but this is certainly a advanced computer. And this is the kind of thing you would have needed in order to generate that kind of music. So this wasn't something that you would have been able to do unless you had an extremely sophisticated computer just to generate the music score itself. So we're talking about very primitive and with a relatively primitive output. Okay, so now we're going to go into the 60s, and we're going to talk about the programming logic and the concepts that were being put into computing into the 60s. A lot of people, as I've read, say that the 60s was kind of like a dead period for artificial intelligence. And I would propose that it isn't necessarily true because, and I'll hope to show you that although your hardware might not have caught up yet to what people were trying to do with artificial intelligence, the cultural adopting of computers into society certainly had occurred in the 60s. And because of that, the ideas and the thinking that needed to be made about what you could do with a computer, for example, Star Trek, talking to the computer in Star Trek, was there. And the hardware had to catch up to it. So I don't think it's valid to say, as I've seen other people say, that the 60s was a dark period for artificial intelligence. As you can see, we're going to talk about human-required interaction, rules programming, and the fact that things aren't quite yet autonomous. This is an interesting slide. The Pacific Bell, or Pacific Telephone, is claiming that the phone company is the largest computer. And they talk about how many phone calls are being made. And I like this slide because no, it's not really a computer, but I like the concept that as early as 1963, people are thinking about the fact that the phone company and the connections and the people talking are acting and simulating computing insofar as the humans are being the computer at this point. The humans are calling a switchboard, the person's making the connection, the operator talking to another person, sharing information, hanging up the phone, calling up another person, and so on. So I do agree that computing is happening. And I do also agree that without this network being developed, you wouldn't be able to have the data collection that comes later. So it's very important to consider these stepping stones in the creation of artificial intelligence. And the phone company certainly is. And of course, they did adopt computers as well to make the switching faster and more reliable. Okay, so McCarthy, in his talks in the 56, 57, 58, created this programming language called Lisp, which was the Lisp processing language. And this slide basically shows you a list of the programming languages that were the quote unquote market share leaders in the 60s. Lisp was not one of them. Okay, so although there were people talking about Lisp as an artificial intelligence language, people that was only being used in colleges and theoretical computing. The grand majority of programming that was happening in the 60s was COBOL, Fortran, and assembly. Algol, PL1, RPG were offshoots, mostly IBM stuff, that were specialized applications, or people who decided they wanted to make a little bit of a better version of COBOL, and so they turned it into a new language. But the most important thing for this list here is to show you that this is a reflection of what was going on at the time. This is what people were using on their gigantic mainframe computers. They were not interacting with their computers. They were presenting decks of, I'm sure you all heard this, decks of punch cards, giving them to an operator. The operator would run the program overnight or whenever it was time for them, and they would get a printout the next day and they would get the results. That's data processing. That is not artificial intelligence as we would think of it today. But you needed to be able to do data processing, to gather that body of data together so you could start storing it and eventually translating those punch cards onto tape, eventually putting those into random access memory drives and so on, so you'd have access to that data. It had to start from somewhere. So think of it like that. And my first job was doing COBOL in the general accounting program at DuPont, and that was very boring. So here's I already talked about the Lisp processing. This is McCarthy's vision. It did, I'm just basically saying it became more popular in the 80s. Is anybody here a Lisp programmer? A little bit. I mean, it's funny when you look back on, at the time I thought how impossible it was. Then when I look at these things today, I have a different appreciation for them. But it was too powerful. It needed too powerful of a computer to be practical. It was too complicated for a lot of people to use. The concept of Lisp processing and iterative processing, essentially object processing in a string like they had it, was close, but it wasn't really what eventually evolved to be a much better process, which was object-oriented programming. But it's an important programming language for artificial intelligence because it was specifically made by people who were talking about artificial intelligence and used for the purpose of doing artificial intelligence, just hoping that the computers would catch up to it. Okay, this is a picture of an IBM 36044. And you can't really see this, but I just thought this was interesting. We're talking about a monthly rental of $13,000 a month in 1965. And all the stuff you needed. Now, if you were an IBM, if you were a sales rep for IBM, one of the things you would be selling was that we're also, in addition to the $13,000 we're paying, or if you want to, you can just pay $539,000 for the computer. We're going to send you a system engineer who's going to be on site and is going to work with you and install this thing, get it up and running, work with you. You're going to have a team of people here. This is a much different thing than we have in today's computers. And those people here that are younger may not realize that back in the 60s, IBM was pretty much the absolute dominant computing company of its time, by far. Univac and some of the other companies were big too, but nothing compared to IBM. And the costs were huge. These were computers that went into banks, insurance companies, bigger universities, military, chemical companies, things like that. These are the computers that ran giant payroll and insurance work. These were not computers that a person would have access to. However, I mean, what I mean by a regular person would have access to. However, at this point, there were a lot of people who were employed in the computer business. They would go to their office. They would sit at some form of a terminal or a teletype or whatever, and they would be in a daily environment of programming and writing code for the first time. So it went from the universities to the workplace. And any major company, DuPont, ICI, whatever, AT&T, they had computer departments. Nothing was outsourced then. You had a computer and you had people working on it. And then you had a manager that said, we really need those numbers. And they would request the numbers and they would write programs that would give output in accounting and sales forecasts and so on. The beginnings of this is in the 60s, and they wanted their money's worth on these computers, and that's an interesting thing to remember. They needed to get their money out of these computers. We'll come back to that. Here's a great example of run on an IBM 7094, which is a descendant of the computer that I showed you earlier, that big one. This is an example of a very, very early chatbot type of response, but it was hard coded. It wasn't an artificial intelligence in the same way. A way a program like this was written, and I'm going to show you something that I found on the internet in a second on the next slide. This shows you the type of interaction. It looks pretty real to you. But if you look at the code, you'll see that it's all they took the I forgot the name of it, but it's a psychologist is required to respond to statements made by a patient in a very specific manner. So that, what is it? Rogerian, right. And I knew it was an R. And what they did was they took the Rogerian book and put it into a computer, and then they wrote rules, heuristics to determine what the person was talking about. They found words, and then the computer responds as if it was a psychiatrist. And it wasn't always really very relevant. And this is me actually talking at once. And you can see eventually I got frustrated. But it's fun. It's a fun program. Has anyone not heard of ELIZA? Okay. But it came out in 64 to 67. And this ended up showing up on a lot of PCs. This was like an early TRS-80 program that you could buy. Okay, and here I got this from the internet. And this is just an example of the programming in the MAD language, I think it was. So it wasn't actually written in Lisp. And if anyone's really interested in the MAD language or any of this kind of stuff, and if something strikes you and you would like me to help you do some research on something, just have to let me know after the fact. Here's another example of the kind of things that were happening in the mid 60s. Electronic calculators. So it was starting to become popular and possible to replace a mechanical calculator. If you had $10,000, you could get something like this. These are also interesting. Again, all this is from the Kennet Classic Library. By 1965, and again, I'm trying to make a point here. Computers were finding their way into society. People who are working, coming home and going, wow, this computer I worked on today did all this great stuff. I wrote all these great programs. Boy, did I help them make a lot of money today at my work, kind of stuff. You had the culture. You can see the punch cards. You can see the readouts, the benefits to business, and so on. So this is 1965 Time magazine, and you also can see the challenge of the computer crooks. The atom, defeated the computer crooks. So as early as 1965, it's so much in the computer culture, so much into culture that you're seeing it in comic books and on the cover of Time magazine. So the adaptation of computers and the potential for them was clearly on the minds of people before the hardware actually was able to catch up to it. This is right from the walls of Kennet Classic. This is a great example. This is Popular Science of May of 1967. And this is an article where a person's actually saying, if you have a modem and you have a teletype, you could actually connect to a computer and work from home. You could actually be at home and connect to a computer. This is, remember, Popular Science. This is like a way out article. People are going, wow, I had no idea you could do this. A lease line, how much would it be? $200, $300 a month just to have the line? And to have a teletype with this era, that teletype, 1967, probably would have been about $1,500. But then you could work from home, right? And or do whatever you want to do at home. And what's important about this is that, yes, you could work from home, but the other great thing about this development and the ideas that it brought about was that people who were running computers and they're spending $13,000 a month want to get their money's worth. And not every business is successful. So some businesses started thinking, wow, we could rent out computer time on our computers at night when nobody is at work, and we could make money that way from them. And if more people were doing this from home, if we gave them a reason to communicate with our mainframe computers from home, we might have a business. So this, in my opinion, is important to the development of artificial intelligence because it is the human beings that drive it just as much as the computers themselves. If people didn't want artificial intelligence, it wouldn't exist. Here's another slide. This is just neat. This is just a movie. I'm talking about 1980 from 1968 or 69. Has anyone seen this movie before? Okay. And here's an example of a dial-in. This is late 60s, and this is one of the earliest that I could find services. Now, if you get yourself a Computer World newspaper from the late 1960s, and you look in the back pages, you'll see, especially if you're in New York, there'll be 3 or 4 or 5 places you can call up just to get some basic information with your computer if you happen to have one at home for some reason, or if you had a teletype at home. So they were already advertising some basic stuff. And this is a little bit more of a commercial version of it, where you can actually a $1 million computer at your fingertips. This is more of a business application, obviously, but $10 an hour, you can actually have access to computers, which at this point were time sharing systems that enabled multiple people working on them at the same time. Has anyone known about any of these things? Hopefully this is new information. Okay, here's another one. This is 1970, and this is a broker terminal. Same basic idea. If you look up at the top there, you can see there's a little display. Interesting. I didn't know that they had. I don't know if that's a Nixie tube.
Someone who works in the space that strip of there
Yeah.
still exists as what's called it's still printer. We still actually just have that up in any complex screen you get it. So.
Oh no, but I mean, is that's not an LCD?
No.
So is it a Nixie tube? What is it?
I don't think that's Nixie, that's probably. Could be plastic.
1970s?
That's more similar on the top.
It's very interesting. So what's great about this is another example of essentially a terminal that enables you to connect with your phone to make stock trades. So if you're on the ski chalet and you hear a stock tip and you want to buy some stock, you don't want to have to go into the office to do it. I guess you use this.
I think it's 8279.
What's that?
It's 8279, the display reader. That's microcontroller. That's what I can think of.
From 1970?
Yeah.
A microcontroller?
Yeah, 8279. It's just like it reads the serial bus.
Oh, okay. I was more asking about what the mechanism was to display it, not how they did it, but what was the actual mechanism of presenting scrolling numbers in 1970? Yeah.
Do you have any picture of Xerox that makes copiers was making a computer called the Xerox Data Systems Sigma 5. I worked on that computer at NASA.
Yeah, I do. I do have a lot of information about the Sigma 5, 6, and 7. I actually have the nameplates and things from it, but I don't have it here today.
You don't have a picture of it?
Not today. If you go to KennetClassic.com, we might have a picture on the website. In fact, I'm pretty sure we do. Somewhere, if you look. And there might also be some on vintagecomputer.net. So if you're interested, or you can contact me and I can, send you something.
Right. I worked on that computer at NASA, at the Goddard Space Flight Center.
Yeah, I have a teletype from one
Uh-huh.
that was donated. Somebody actually as the SDS down at the bottom before they were purchased by Xerox.
Right.
Yeah. Yeah. No, that was from this time period.
But I think they gave up making computers and went back to copiers, right?
Well,
Xerox.
SDS got purchased by Xerox, and then Xerox got out of the computer business into the 80s. Yeah, they lasted for a little while though. Yeah, but anyway, But I'd be happy to talk about that, later if you want to.
Right.
This is just another example, again, from the library, it's just talking about how the computer's forecasting growth, and they're writing an article about it. And this is a form of artificial intelligence, insofar as it's taking a lot of data and creating a conclusion on its own. Now, it doesn't talk about exactly how it did it, but that's the kind of thing people were doing.
Also, was it determined whether it was correct or not?
Well, they were actually kind of, in the article, they were kind of debating that, in human terms, what the promise of decade of peace and welfare, I mean,
Right for Vietnam.
Yeah,
So,
and the numbers.
so they're basically saying, boy, we hope that's true, I think
Yeah.
it's the best way to
We
put
do
it.
know what the GMP was in the far flung future of 1980, though, so is it actually correct?
It was much more than that.
So it was not.
So they were underestimating.
Okay.
I don't have every GMP memorized, but
Yeah, no,
I can tell you that.
I'm just curious that it made a prediction. Curious. to know.
Yeah, so they're basically
Correct.
saying that it would double, GMP would double by 1980, and the only way you could say that was if you didn't account for inflation, because inflation just shot it.
They didn't have for like,
Yeah, yeah. And how do you, you're 2 to 3% inflation per year, so that was wrong. They were wrong. Yeah, exactly. So this is interesting. I love this kind of stuff because reading about what people were thinking was going to happen based on what they had then, using computers to do it, is a feedback mechanism for the next time you create something like that. And when you program it with your artificial intelligence, you are taking into account the fact that this had pluses and minuses. And so you've tried to solve these problems so that the next generation of your artificial intelligence has awareness. And that's really, I think, what's most important about artificial intelligence is that that the human being, it's like a ping pong back and forth. Is this right? Okay, let's make the computer fix that problem and then solve another problem. And it goes back and forth and back and forth. More and more data, more and more cultural involvement. All credit cards are on computers now by 1970, 71, or a lot of them are. All the bank statements, all the census, all this information is being brought in, and people are willingly giving their information. They're willingly getting charge cards, and they're willingly getting their statements sent to them because the companies that survive are the ones that can print the invoices using a computer versus doing it by hand. So you don't have hand invoicing by the 1970s. The computers have to do that. You don't call up an airline and have the airline write down who's going to get their reservation. It's done on a computer. Okay. Now this is a good time for me to bring this one in here. This is the Tridex Muse. This is by Marvin Minsky, who's one of the guys from 1956 in that group, Dartmouth. By 1968, 69, 70, he and a team of people were just messing around. Honestly, I don't really see any other explanation for it. And they wanted to improve on the ILLIAC generated music and other computer generated music. So they created a device that had what they call an artificial intelligence music generating system. And it's complicated, but I'm going to just explain it to you this way. These levers here create intervals and patterns of intervals. And are any of you musicians here? Okay. When you're writing music, let's say you're doing Mary Had a Little Lamb. Okay, you're just doing a simple song like that, or Daisy, or any of those simple songs. You have a melody, and that melody can be written on sheet music, in notes, A, B, C, D, E, F, and G. Okay, and the pattern and the duration of those notes played, and the intervals between notes and so on, generates the music. And human beings are made to make music. We've been making music our entire existence as humanity, and before we were humans, or evolutionary. So it's very challenging to expect a computer to be able to do that, as was evidenced by the biggest computer they could find and the best programmers they could get with artificial intelligence made that very tension-oriented music that we heard. I'm now going to play for you Minsky's shot at doing the same thing from 69, 70. This is all discrete logic chips. So inside of here is a series of sliders that control the resistance of the voltage regulators and so on to time when the intervals will occur and when the notes will happen and how they interact together. And the artificial intelligence component of that is when two competing tones that are supposed to play at the same time have to play. The system determines which one, it's some sort of randomness factor, whether to play one or the other. And every time you play it again, it does it differently. So you turn it off and on again, it reinvents the same song. So I'm going to play this for you. This is called the Tridex Muse. This is the first sequencer computer. So now I could change the intervals a little bit. And these lights, when it comes around again, so I'm basically messing with it. And you might have heard something like this in a video game 10 years later. So what I think is interesting about this is that in 1969, Minsky essentially invented the sound that would eventually find its way into the video games in the later 70s. And what he was doing was basically making a wide open system that could generate any tones and any intervals. And what the video games did is put that onto a chip and just kind of hardwire the explosion sound and the various other sounds, or program them and then save them in the memory.
Change some of the other sequence patterns using those things. What does that do?
Well, if you read the manual, it talks about all the different intervals. That's what I was trying to explain. So what you're doing is you're building relationships between one note to another. So you're jumping to a fifth, and then you're jumping to another fifth. So you've got a scale that's kind of going up and down like a sine wave in fifths. And then if I want to, I can change it so that, and I have to look up which one's which, but I can change it. I mean, you can sit there and play with this thing for hours, you know what I mean? But well, maybe you can't, maybe I'm seeing, but you hear how it's different now?
Yeah.
And if you actually sat down and wrote it out, you could figure it out. You know, so whenever I'm really seriously doing this, I put them all together. And then so it's just going doo, and then I break it apart. And then I write down what the intervals are so that I'm not trying to have to refigure it out again. You have a question?
No.
Okay. But again, that is really annoying after a while. You know, like my kids will run downstairs and say, "Dad, I'm trying to sleep." You know, so it's interesting, but it is artificial intelligence in after a fashion from that time period. Yeah. 5 minutes. Okay. All right. We're at slide 36. Okay. This is a picture phone. Computer dating.
Yeah.
This is the first computer dating ad. So I think this is really interesting because we're talking about expert systems and the expert system of the ability to you fill out a questionnaire, you put it into the computer, and the computer spits out your match based on your compatibility. Here's another thing I find really interesting. The linking ring is for magicians. And this is an article, for whatever reason, somebody wrote an article about pattern recognition, and a computer's, now everybody knows who this is, right? Abraham Lincoln. But why do you know it's Abraham Lincoln? You see what I mean? What is it in your brain that tells you that's Abraham Lincoln? Computers at this time were starting to play with the concept, the artificial intelligence concept of determining human limits to interpreting and understanding recognition patterns, which they've been working on since the 50s, but the latest advances in computer recognition technology is manifested in this example. So in 1971, a computer was being exercise are generated in order to determine face recognition. Now, today we have facial recognition on your phone, right? Well, this is where this kind of stuff got started, okay? And I have 5 minutes. Hey, Prolog is great programming language. This is like a next level programming language. And you know, Prolog, it's just object-oriented programming. You have text adventures. This is a kind of going past ELIZA. This is an example of artificial intelligence that you ask questions and it guides you through a maze to get to the end. This is just funny. I'll give you a second to read it. And that's it. Okay, Trenton Computer Festival. How many more minutes we got? 4, okay. The very first Trenton Computer Festival, I wanted to make sure I showed this. Claude Kagan did a talk in N111, wherever that is, about the future of home computers. I would love to have been here and do that. This is the very first finished Trenton Computer Festival. And this was a talk that he did. And my point here is just to show you that this was always in the culture and always people thinking about it.
Do you want to look up the resistors?
I would, except I only have so many seconds left in this thing. Here's another example of a early version of, this is a book where you choose your own adventure. This I found a scrap of paper in somebody's materials that were donated in Chicago. This is the original CBBS bulletin board.
Was that Chicago?
Yeah. So this is from the, and the point here is just to say that people were starting to dial in. So now it's the mid-70s and it's becoming practical to dial in. Here's another interesting service. This is around 1978 to 81. Ask It, a very early version of a program which you could call into and get business knowledge. It tells you how it works. AI and personal computing. This is a book based around the Z80 computing. So they were actually trying to write artificial intelligence after a fashion in a 64K computing environment. Here's an embedded artificial intelligence thermostat. I'm assuming it's had a 6502 in it. This is for Rutgers. This is a dial-up service from 1983. Did you know that Rutgers had a dial-up service in 1983? Anybody in New Jersey actually could use this, but this one was made specifically for Rutgers in a partnership with AT&T. This is an example of an expert system that was supplied by the university. The people who called into and actually had it on their television sets. You had a little console, and you would actually communicate with it. Okay, and then the next thing here is now we're starting to get modern. So now we have, we're now in 1985, and we've got we're starting to come up with autonomous machines. There's another one here. These are some of the examples of kinds of programs that are being done: diagnosing infections, identifying organic compounds, looking for mineral sites, and so on. So we're really starting to get sophisticated by the mid-1980s. And then the mid-1990s, we have a quote from Minsky that you can read. And then I'm just going to really quickly hand these out. Just hand these out and bring them right back, okay? These are examples of handheld devices that were before the smartphone. There were intelligent agents that would enable you to set your calendar, enable you to check your email, not dial in, but it wasn't wireless, but these are examples of that. The one that the first one that's the very first one from 1978. And then the Newton is Apple's popular product. And this is an example of neural networks, which I guess I'm out of time. So if anyone wants to talk about this in the future, they can with me. This was a lot of fun to put this talk together. I apologize how fast I had to go. This could have been broken into 5 lectures probably, or it could probably take a little bit more time with it. But I'm happy to stay after and answer any questions that you might happen to have about artificial intelligence history. Or if you have a specific project that you'd like to work on, I would love to work with you on. All right, thank you.